Today, we're going to be talking about the effect of soil pH on redworms and specifically looking at their CO2 production and behavior. My name's Chance, and I did the study with Corbin, Aiden, and Amy. So kind of talking about why we chose redworms for our study is really just because they are such a crucial organism in our daily lives. They're decomposers, and they're great decomposers at that. They're found in all parts of the world, and they can decompose any kind of organic material that they need to. But one thing that we are seeing a lot in our world now is some changes to that because of things such as waste runoff, manufacturing, and especially farming practices that involve nitrogen. We're seeing soil pHs change across the world. And what that is doing is affecting the lives of these decomposers. So we kind of want to take a closer look at that and find out what pH changes do to these decomposers and also what pHs are best for them. We kind of base these off a couple studies we found because no one study really had all the information, but one main one we did use was from the Chinese Harbin University of Science and Technology, and that kind of gave us our pHs to start with from about 5 to 8, and that's how we developed our hypothesis.
So basically for our hypothesis, we wanted to formulate that to then write out our procedure. We've essentially formulated around our research question, which was, does soil toxicity have an effect on the activity of redworms over the span of 3 minutes? And then, of course, we hypothesized we would measure that via a CO2 meter. We essentially understand that worms' natural environments consist of a pH of neutral 7. So for our experiments, our students believe that at 7, the worm's activity would be the highest, with that reflected in high levels of CO2 output. Contrarily, we hypothesized that in lower pHs, such as acidic environments and that of alkaline, that the CO2 production would be much lower. We basically formulated these around the studies previously mentioned, and via the research question, it helped us formulate our method and actually structuring the experiment.
How do we complete our experiment? We used 3 redworms for each pH level, leaving a total of 12 redworms. We then cleaned each worm with Q-tip and water and measured them in Petri dishes. For our solutions, we used spray bottles and a Pasco pH probe to measure the pHs of our solutions, using lemon juice and wood ash to give us a pH as we desired. We then gave the worms 10 minutes to acclimate individually before testing them with the Pasco CO2 monitor for 3 minutes. Once that was done, we put them all 3 for each pH group together to see what change that had on the worms. The point of our experiment was to see how the CO2 output changed and the behavior of the worms at different pH levels.
We found that the worms that were subjected to a pH of 7 produced the lowest amount of CO2, followed by the pH of 8, then 5, and finally 7, as seen in the graph. This aligned with the worms' behaviors, where we observed in the 2 more acidic tests the most movement. Well, at pHs of 7 and 8, we saw less movement, and the movement that we did see was less urgent and more docile. With regards to the variability, in both acidic trials, we saw that the standard deviation was significantly greater than that of the 2 more basic. There were several trials with quite small worms that all saw a tremendous production of CO2, like per gram. As a final note, although the data doesn't show significant outlier in the pH of 7 test, a worm was lost in the CO2 meter and therefore unable to test its CO2 production within the group.
All right, so all in all, despite our sadly lost worms, we concluded that our hypothesis was actually not supported by the results that we predicted. What we did observe in our results was that a pH of 7, in fact, had the lowest amount of CO2 output. And then following after that, the highest amount of CO2 output occurred at the pH of 6. And we formulated that these might be because of 2 reasons. This could have been a stress response happening by the worms when they experienced a new environment. Similarly, we also understand that the pH changes were not enough to like elicit strong reactions from the worm. And that's reflected by the Wu et al. Research article that we found. Although our data did not support our results, we understand that in our trials that the applicable cases that we have found relate to the worms in the sense of production, manufacturing, and farming. The way students can apply this lab data to the real world lies within pollution and our changing environment constantly. The amount of pollutants we put up into the environment and the changes in pH we observe do cause discomfort to the worms. That's reflected in the data at pH of 6. And now we understand that how the CO2 of the worms is affected when they have a pH of 7. All in all, students can apply this knowledge outside the lab, and that we can learn that going forward, if we were to repeat this lab, we would probably do more trials and repeat the same controls to hopefully obtain the same observed results. And that way we would demonstrate this data to be more applicable in real life. Thank you so much for watching our presentation.